Hi guys, so 58 was the most frequently asked question. The only other one was 57. Um, so I'm going to jump on 58 first just because it was so frequently asked. But there's two circles of radius 4 being tangent to this graph at a specific point. Find the equations of these two circles. I'm very visual, so my first point of attack is to kind of try to figure out what that graph looks like. So if I pick an x coordinate of 0, let's say, when I plug in 0, y would have to be 0. So 0, 0 falls on that curve. If I pick like an x coordinate of 1, then what squared equals 4 times 1? What squared equals 4? It would be plus or minus 2. So this is 2 points, the point 1, 2. And the point 1, negative 2. So we've got sort of this going on. I'm not going to pick 2 because that would make 8. Nothing squared equals 8. Nothing nice anyway. 3 would make 4 times 3 is 12. 4 would work nicely. If I pick 4, 4 times 4 is 16. What squared equals 16? It's plus or minus 4. So I've got 4 and then plus or minus 4. So this is really just like a sideways parabola. And they're looking for the two circles that are tangent to that function at the point 1, 2. So right here. So I'm envisioning there's got to be some circle over here and some circle here. They're already telling us that the radius is 4. Now the big question is, where is that center? Because if you're writing the equation of a circle, it's x minus h squared plus y minus k squared equals r squared. And we just need to find the center of this one and the center of this one. We already know that the radii are 4. So x minus h squared plus y minus k squared equals really just 16. But where are those centers? And so that's where this whole normal line talk is going to come in, because if we find the slope of this sideways parabola here, then kind of a little tap into geometry, that the radius of a circle to any point of tangency has to be perpendicular. So whatever the slope is here, we need this line to be perpendicular. So the function's derivative is 2y dy dx equals 4. And then when you solve for dy dx, you get 4 over 2y, you get 2 over y. So the derivative at that location is 2 over whatever the y coordinate is, and the y coordinate is 2. So 2 over 2, which is 1. So if this has a slope of 1, then this has the opposite reciprocal slope of negative 1. And by the way, so does that one. So we know that the slope from the center to the point 1, 2 has to be negative 1. So the perpendicular slope has to equal negative 1. And we also know that that distance has to be 4. So we're going to call this point HK. We don't know where it is, but we're going to call it HK. And we know that the distance formula between HK and 1, 2 has to equal 4. So the distance equals square root of where you do the x minus x, so h minus 1 squared plus k minus 2. That's your like x1 minus x2 squared plus y2 minus y1 squared has to equal a distance of 4. So we know that about our distance between those 2 points, but we also know that our slope between those 2 points, so y2 minus y1, which is k minus 2 over x2 minus x1, h minus 1, has to equal that slope we want to equal negative 1. So this is, so on top of bringing in geometry from the sense of the radius needing to be perpendicular to the tangent line. We're also bringing in the distance formula, slope formula, and a system of equations. So really all inclusive of all your algebras and geometry here. So if we wanted to solve this, it would be a system of equations. I would probably just multiply both sides by h minus 1. And k minus 2 equals negative h plus 1. So I would probably go up here and plug that in there. So I'd have 4 equals square root of h minus 1 squared plus, I'm going to call this 1 minus h. That's my substitute. Square both sides. I get 16 equals, and then I'm going to actually square this out. H squared minus 2h plus 1 plus 1 minus 2h plus h squared. Combine like terms, 2h squared minus 4h plus 2. Subtract my 16 over. Get rid of the 2. And I did something wrong. Son of a gun. That. Maybe I didn't. Maybe it's not a nice answer. Maybe I need to do the quadratic formula. I'm just going to power through. Opposite of b plus or minus the square root. B squared minus 4ac over 2a. 2 plus or minus 4 plus 28 is 32 over 2. This is root 16 root 2, so that's going to be 2 plus or minus 4 root 2 over 2, which is 1 plus or minus 2 root 2. So that's my h coordinate. H equals all of that. And it makes sense that there's two answers. So 1 add on 2 root 2 is probably going to bring you to the x coordinate of this one. 1 subtract 2 root 2 is going to bring you to the x coordinate of that one. So those are your two x coordinates. So I've got h comma k, and my two h possibilities are 1 plus 2 root 2 comma something, and 1 minus 2 root 2 comma something. So it's not nice, but then I need my k values to go along with that, and I'm trying to find the best place to go back and find that. If I know that h is this, then I'll probably go back here and say that k minus 2 has to equal negative. I'll do the 1 plus 2 root 2 first. Negative that plus 1. So it's going to be k minus 2 equals negative 1 minus 2 root 2 plus 1. That'll cancel. Add 2 to both sides. So your k value is 2 minus 2 root 2. And that's the k value that goes with the 1 plus 2 root 2. If I do the same thing, but with my h coordinate of 1 minus 2 root 2, I'll do it here. Try to fit it all on the same page here. So k minus 2 equals negative, and I'm going to go with this h value, distribute, those cancel, add your 2 over, 2 plus 2 root 2. Okay, so my two equations, if those are my two potential centers, and again, each of those are starting with the y coordinate of 2, add on 2 root 2, and subtract off 2 root 2. So actually those make sense visually to me anyway. So the equations for the circle, if we do circle 1 and call this circle 2, circle 1 is going to be x minus my h coordinate, so I could distribute that, or I could keep it in parentheses if I wanted. X minus h squared plus y minus its k value squared equals 16. And then the second one is going to be x minus my x coordinate squared plus y minus my y coordinate squared equals 16. So, typical type of upper level math problem that took the entire page and was not pretty at the end, but those are our two circles that are tangent to that sideways parabola at 1, 2. So, hope that helps. And I'll add on 57, which I already wrote down. Show that the normal line at any point on the circle x squared plus y squared equals r squared passes through the origin. So again, to get a visual, x squared plus y squared, the center is definitely at 0, 0, and the radius, who knows what it is, we'll just call this r, we'll call this negative r, negative r, and our circle does something like this. So it wants us to show that the normal line at any point on the circle. So I'm going to pick just some arbitrary x1, y1 point on the circle. That's just the first point I'm coming up with on the circle. We want to show that the normal line, so here's the tangent line. That's going to be the derivative of our curve at that point. And we'll opposite reciprocate that to get the new slope, and that new slope with that point can write the equation of the line, and we need to prove that it goes through the origin. So the first thing I'm going to do is find the slope of the tangent line at x1. So the derivative of this is 2x plus 2y dy dx equals 0, because r is just some constant radius number, so the derivative of any constant is 0. When I solve this, I'm going to get that dy dx equals negative 2x divided by 2y, which is negative x over y. So the derivative, or the slope, at this location when I plug in x1, y1, is negative x1 over y1, which means my perpendicular slope of my normal line that I'm going to write an equation for in a second is the opposite reciprocal of that, so positive y1 over x1. So when I write the equation of the line with that slope and that point, my equation becomes, for this normal line, y minus the y coordinate, slope, times x minus the x coordinate. And that's the equation of the normal line at any generic point, y1. Now, how do you prove that 0, 0 falls on that? Well, you plug in 0, 0 as the other point. So if I plug in 0, 0, I'm going to get negative y1 equals y1 over x1 times 0 minus x1 is going to be negative x1. And what I'm going to get when that cancels is negative y1 equals negative y1. A true statement tells me that 0, 0 does fall on that normal line. So that one's a little bit more arbitrary. I almost would venture to say, even though it's shorter, it's tougher to wrap your head around. But a lot less playing into it as far as tapping into geometry and stuff. So hopefully that helped, and onward tomorrow.